So in this video, I'm going to show you just two examples of using substitution a little bit more creatively. So I'm going to show you these two examples. So let's just jump right into it. I've been making too many videos today. Okay, so when I look at this first problem, so we've got dx over cosine squared tangent of x. All right, so the thing about this is that like your first hint, I don't know. I don't know what I would do if this were me, because I guess I'd have cosine x squared tangent x. And obviously, if I take the derivative of this, it's going to be kind of crazy, right? Because this is going to require the product rule, and then this will require the chain rule. So there's kind of a lot into this. So in looking at this, okay, I know that this is not right. And then let me clear some space. I feel like the second thing I would want to try is to rewrite this as cosine squared x, and then instead of tangent x, maybe I'd write this as sine of x over cosine x. So this would probably be what I would naturally do to see if I could solve this. So I would get cosine x sine x. So remember though, in the context of this, so this would be 1 over cosine x sine x, which, I mean, I could break this up into two different parts, but like, so I would get secant x cosecant x. So the thing is, like, this would probably be, when I first look at this, like my next thought of like, oh, I'll just split it up like this. And I can see now that this is not any antiderivative, right? So this is what tells me that I'm going to have to be a little bit more creative in my substitution. So I'll clear some space. So when this happens, now you're just kind of playing around and taking a stab in the dark. And so if I were to say, I'm just going to randomly set u equal to tangent of x. So if I take the derivative of that, that I know is secant squared x. But if I think for like an extra minute about that, what is that? So this would be equal to 1 over cosine squared x dx. And at last, so this is actually what we needed to do. So I've got 1 over cosine squared, right? And then I've got my dx right there. So now I can see that I can rewrite this as 1 over u dx. That's actually it. That's all I have to write. And so then this becomes the natural log of tangent x plus c. So that would be it for that one. So it's a little bit more creative in like how you approach your substitution. So let's look at another one. This is another kind of creative way to think about your substitution. So in this case, I feel like it's just screaming for what I need to do here. So my first thought is that I want to just substitute out that weird looking exponent. But here's the thing. I don't want to like take the derivative of this as is, because I know some things about natural log. One of the properties of natural log is that when I have an exponent like I do here, I can bring it out in front. So another way to write u is 3 times the natural log of x. Now I would much rather take this derivative than this derivative, right? So now, like, this is what I mean by being creative. You can make this choice. And now that I've set my du equal to this, oh, that actually is what I have here, right? So what I'm going to do then is I'll put 1 over 3. Let's see, actually, we'll write this as 1 over 3 du equals 1 over x dx. And then this 16 here, I can bring it out. So this is going to become 1 over 3 times 16, 2 to the u, well, really just 2 to the u du. So that's everything substituted out now, right? And so now from here, this is going to be 1 over 48, 2 to the u, let's see, maybe times 2 to the u over the natural log of 2, which is going to be, let's see, 2 to the natural log of x cubed over 48 natural log of 2, and then don't forget the plus c. So these are slightly more creative ways to kind of think through your substitution. So feel free to give those a try. If you found this helpful, please consider hitting the like button. And I will catch you guys in the next video. Thank you for watching.